In this video, we're going to solve this quadratic equation 5 ways. You want to pause the video, see how many ways you can do it. Go ahead, then I'll be back. Okay, so the first way is going to be factoring. One side is 0. So we try to factor the left side. We look for common factors. No common factors other than 1. So we put two sets of parentheses here. And we look for factors of 10 here, factors of negative 18. That'll give us this negative 3x for the middle term. So for 10x squared, we can try 2x, 5x, 10 and 1. Play around with these. The third term is negative, so we know the signs in the parentheses are going to be opposite. One will be positive, one will be negative. Play around with the factors of 18. And there's different techniques for factoring. But once you've done enough of these, you can figure out what the combination is going to be. I'm going to use 3 and 6 for the 18. And I want to come up with a minus 3x here. So that means this one should be negative here. This one should be positive. So let's check it out. 5x times 2x is 10x squared. 6 times negative 3 is negative 18. So we multiply these out. That's minus 15x. And then multiply these out. That's 12x. Add them up. And that does give me the minus 3x. So then we just set each factor equal to 0. The product of two factors will be 0 if one factor equals to 0, or they're both 0. So we simply set both factors equal to 0. Solve each linear equation that we get for x. So 2x minus 3 can be 0, or 5x plus 6 can be 0, solving for x here. Adding 3 to both sides. Isolate the x term. We get 2x is equal to 3. Divide by 2. These cancel out. X equal to 3/2. This one over here, add a negative 6 to both sides to isolate the x term. We get 5x equal to negative 6. Divide both sides by 5. These cancel here, so we get x can be negative 6 over 5. So for a quadratic, the degree is 2. So you expect at most 2 distinct solutions. You could have a repeated solution, but in this case we get 2 distinct solutions, 3/2 and negative 6/5. And this is the first method you always want to try. If you're given a quadratic equation to solve and they don't give you an option as to what method to use, you can use any method you want. I would go with the factoring first, and if it turns out that the quadratic doesn't factor, then you want to go to the quadratic formula. One side has to be 0 for this to work now. So that's one way to solve the equation. Using the quadratic formula, the equation has to be in the form ax squared plus bx plus c equal to 0. And then you're going to plug the coefficients of the equation here, the coefficient of the x squared term, the x term, and a constant term. Again, you still want one side to be 0. So if it's not, one side is not 0, you rewrite it. And then where you have the b, you replace that value. You have a minus there. You have a b under the radical. And then a and c is part of this radicand. And then the denominator, you have 2a. Just plug it in there. But it has to be in this form. Ax squared plus bx plus c. So if it doesn't have the x term, that means b is 0. So you don't really need the quadratic formula in that case. That one's fairly easy if the b is 0. If the b and the c are 0, let's say you have something like 2x squared minus 4 equals 0. Well, in that case, I would just bring the 4 over. Divide by 2. You get x squared is equal to 2. Take the square root of both sides. X then can equal 2, or will equal to plus or minus the square root of 2. So it makes it easier if some of these components, the b or the c or both are 0. Now you got to have a square term, otherwise it's not a quadratic, it's just a linear equation if it just has, say, an x term. But those are even easier to solve if some of those terms are missing. So let's go over here then and plug in. So x for this one side is 0, is equal to minus b. So in our case, the minus b, or the b, is negative 3. So minus that will give us a positive 3. This is plus or minus. Then we have the radical, square root of, and then it's b squared, so that's a negative 3, quantity squared, so that's 9. Then it's minus 4 AC. The A is 10. Just put a 10 there. And the C is negative 18. And the denominator, the formula has 2A. So that's 2 times A, which is 10. So it's going to come out to 20. So then you just do the calculations here. So this will be 3 plus or minus square root of 9. And then notice here negative and a negative here. That'll give you a plus right here. And then you just multiply the 4, the 10, and the 18. And we get 720. And that's over 2 times 10, which is 20. So this will give us 3 plus or minus the square root of 729. It's over 20. Now if it turns out that the number here under the radical, the radicand, is not a perfect square, then your answer is going to have a radical expression. You simply simplify the radical. Unless they ask you for a decimal approximation, then you can use the calculator and take the square root of 729 plus or minus, add 3, divided by 20. But in this case, 729 is a perfect square. It'd be 27. The square root of 729 is 27. That's over 20. So in this case, then we say, okay, x is equal to 3 plus 27. That'll give us 30 over 20. One possible answer. The other one would be 3 minus 27 will be a negative 24 over 20. And then you just reduce these. Notice here, zeros cancel out. I get 3 halves. And here, minus 24 over 20. We can reduce that, divide by negative, or by 6 rather. No, by 4. Yeah, divide by 4. This will give me 4 into negative 24 will be 6. And 4 into 20 would give me 5. So again, get the same solutions. X is 3 halves. Or it can be negative 6 fifths. So that's the quadratic formula. And again, if you're given the option, I would do factoring first. And if it factors, you're good to go. If it doesn't factor, then I would use the quadratic formula. And then depending on this number under the radical here, if it's not a perfect square, you could have a solution with a radical, or this value here is negative. You're going to have complex or imaginary solutions. So your answer will have the imaginary unit, the I. Now the next method is the method of completing the square. And that's how the quadratic formula was derived. They took an equation of the form ax squared plus bx plus c equal to 0, and they completed the square and they generated the quadratic formula. So for this to work nicely, one way to do it is just divide everything by the coefficient of the x squared. Makes it easier to complete the square. So I'm going to divide everything by 10. So that'll give me a 1 x squared. Over here, this will be a negative 3/10 x. And at the same time, I'm going to take the 18 over, the negative 18 over, make it positive. So this will be 18 over here, divided by 10. And then I'm going to reduce this. Divide by 2. This will be 9 fifths. And then to complete the square, once you've made this coefficient here 1, you take half the coefficient of the linear term, in this case x, multiply that by half, to 1/2. And that gives me a negative 3 over 20. And then you square that. This will give me 9 over 400. And that's what you add to both sides. So this will give me x squared then minus 3/10 x. And then I add 9 over 400 to complete the square. But whatever I add to one side, I have to add it to the other side. So this will give me then on this side, on the right side, 9/5 plus 9 over 400. Now the left side should be a perfect square now. If you take the square root of the first term, x squared, the square root of that is x. Whatever this sign is, it's minus. If it's plus, you put a plus. And then square root of the 9 over 400. Square root of 9 is 3. Square root of 400 is 20. And then just square it. That would give you what we started there. So you square this binomial, it'll give you x squared minus 3/10 x plus 9 over 400. And then on the other side, in order to combine these 9/5 and the 9 over 400, we have to have the same denominator. So to get 400 on the first fraction, we're going to multiply this by 80. So this will give us 400 then, and then 9. And now we can add a 9 times 80 plus the 9. That'll give us same sort of thing we got with the quadratic formula, 729 over 400. Now we have it in this form right here. It's like we have x squared is equal to 25. Take the square root of both sides and you have it. Well, in this case, we take the square root of the left side. You got x minus 3 over 20. That's what we get. It's a square, perfect square. Take the square root. And of course we saw earlier that 729 is a perfect square. 400 is a perfect square. 20 times 20. So the square root of 729 we saw was 27. And the square root of 400 is 20. So we saw for x here. And this is a plus or minus here. Take the square root. We get, otherwise you're going to lose one root. You only get half the answer. So take the square root plus or minus. So that tells me then that x will equal to, add 3 over 20 to both sides. So it'll be 3 over 20 plus or minus 27 over 20. Now we can finish this up then and say, okay, 3 over 20 plus 27 over 20 will give us 30 over 20. Reduce that down to 3/2. And then 3 minus 27 over 20 gives us a negative 24 over 20. Again, reduce that down and we get negative 6/5. Same answer. Again, what you want to do it, if you have an option in your equation factors, that's the way you want to go. Here we're just showing that you can get it several ways. And sometimes your instructor might tell you that they want you to know the particular method. And they might say you use the quadratic formula or use the method of completing the square. Now the other way, graphing, use the graphing calculator. And again, what we do in the graphing calculator, we take this right here, this part right here. One side is 0, and that's your y, or your f of x. That's your function. And then we graph that. And wherever this graph intersects the x-axis, that creates the zeros. So we take those zeros and plug it into this left side, and that's going to give us a solution because it's going to give us 0. So what we're doing here is finding the zeros of that function. So in this case, I go to the graph, and I already have it entered here. 10x squared minus 3x minus 18. It's entered there. So I go to the zoom, and I'm going to use the 6th z-standard method to graph it. You can experiment with that. And so you can see there's the graph. There's a parabola. It's one that opens up, so you can see right there on the left side of the x-axis, or the y-axis I should say, it crosses there at the x-axis there. And on the right side of the y-axis, it crosses over here on the x-axis on the left. So what we do there is go to second, and then hit trace. We're accessing calculate there, and we want the 0. So hit 2, and then notice it asks for a left bound. So I put the cursor there. on the left, and I hit enter. And I notice on the lower left, it asks for a right bound. So I go past that point where it crosses. As long as it's on the other side, and then hit enter. Now it's asking for a guess. You can ignore that and hit enter. And here I'm using the 83 plus calculator. And there it tells me I have 1, 0. Notice here it's x equal to negative 1.2. And what confirms that this is a 0, of course it tells you, and then the y value has to be 0. So negative 1.2 and 0 is where it's one point that the graph crosses the x-axis, and that of course is going to be a solution to this equation over here. So the negative 1.2 corresponds to the answer we got. We left it as a fraction, negative 6 over 5. If you convert this to a fraction, you'll get negative 6 over 5. Now let's go to the other one then. So again, it gets second, calculate. Again, we want a 0. Now we want this one on the right side of the y-axis. So left bound, hit the cursor here, move the cursor, hitting the right arrow here all the way until it gets close to the x-axis there where it crosses. There it comes. Okay, that's pretty close there. Let's see if it works. Otherwise, you move it back. But let's say, I'm going to move it back just to make sure. Right there. Hit enter. Now that's for a right bound. So I'll go past, hit enter. Ask for a guess, lower left there. Just hit enter. And there it tells me. The other 0, which of course is a solution to this equation, is 1.5. That of course corresponds to the 3/2 that we got. So either way, we get 3/2 and negative 6/5. Now the other way we're going to solve it is by using what is called a CAS graphing calculator. This is simply a calculator that has a computer algebra system built in. So it not only gives you numeric answers like we had here with the graphing and of course other methods, it gives you symbolic answers. So this calculator will factor expressions, combine rational expressions, reduce rational expressions, or solve equations, which is what we're doing here. The one that I'm familiar with that I used in my classes when I was teaching is the 89. This one I have it set to auto. So you go to mode here on this one. I have it set to auto. So if you try to solve an equation on this one, it'll try to give you an exact answer if it has one. Otherwise, you can hit the diamond here and get an approximation. So on this one here, what we do is go to F2, and the first choice there is to solve. And that's what we're going to do, solve. So I hit enter, then I just enter the equation. So it's 1, 0, and then it's x squared, so x exponent, then minus 3x, then a minus 18, and then that's equal to 0, and then a comma here, and here I indicate what variable. If you don't give the variable, the calculator will give you an error. So you have to tell it what variable. Sometimes you could be using y or whatever. Generally it's going to be x, but you have to tell it. So put an x there. You don't have to do this for every procedure, but solving equations you have to indicate the variable. And then I close the parentheses here. And let's hit enter. And it tells me the solution to this equation is x equal to 3/2 or x is equal to negative 6/5. So that's how you can solve it using, and this of course will solve trig equations also. You have to know a little bit more to solve trig equations, but this is for just standard equations, whether they're linear equations, polynomial equations. You use this procedure, the calculator will give you the solution. Sometimes you have to adjust if you want imaginary solutions, but it's a similar technique, and I've covered those types of videos before. But for right now, that's the way you can do or solve this type of problem 5 different ways. Thanks for watching. We'll see you next time.